For more information, please visit SGMAK Associates website.
Hi, here is a short clip on statistical reasoning. Just my thoughts. As an instructor in the School of Engineering for over last 30 years, I have got some insight, and I'd like to share that with you. And it's almost my as you teach over the years, you get some experience from that process, and that affects your teaching. What do you think is important? How things should be done? How the topic should be communicated to the student in a meaningful way. So I'm going to share some of my thoughts with you, maybe in a maybe series of clips, short clips like that. What I'm talking about here is can be also part of a course in probably in statistics in engineering curriculum, or maybe in any curriculum. As a matter of fact, everybody needs to understand statistical analysis of data. Why you need it? Because the real world is affected by uncertainty. That means, just take a simple example, demand for a product. You are running a company, you produce a particular product, you sell it to the market. You definitely would like to know how many you would like to maximize the amount that you can sell. So you'd like to, higher demand is better, but how much it will be demanded is not known with certainty. If I've been able to sell 100 units this month, doesn't mean I'll be able to sell 100 units next month. We have a lot of forecasting method. We use that to get hold of the process. But the bottom line is, real world processes are affected by uncertainty. Example that I gave, demand, it will not be the same every month. It will go up and down, and we're trying to understand that better so that we can tune our production process accordingly. Okay, so whenever we have a real world, when you're watching a real world process and process affected by uncertainty, we typically represent it by a random variable. Demand for a product is an example. Is a random variable, and so what happens? We try to understand it through data analysis and understand the variation. A variation creates a problem because you can't apply your resources in a production setting in tune with the variation. If the variation is too high, if variation is too much, you have too much of a pulsation, hiring people, laying off people, those sort of things. So basically what you want to do is we try to understand the variation and manage it accordingly in running a manufacturing process. So we represent it, any real world processes when it's affected by uncertainty is represented by random variable. So demand for a product is a random variable, and a random variable could be either a discrete or continuous in nature. If I'm selling how many units of car I can sell next year or next month, that's a discrete random variable, and in this case happens to be integer also. I'm not going to sell 10 and a half cars, whether it will be 10 or 11. So that's the discrete values, discrete integer values in this case. If you think about how much fertilizer do I need in the next month, if I'm producing fertilizer, how much fertilizer will be demanded in the next month, there's a seasonal variation of that. That's an example of a continuous random variable. Now, what we do in statistical analysis, random variables are typically represented by a statistical distribution. Now, We'll start with univariate distribution. We are looking at one thing at a time, just the demand of the product. Later on, as you move on in deeper, you may watch 2 or 3 variables how they move together simultaneously. When you get into multiple variables together, there's a multivariate statistics. But the idea is a random variable will be represented by a statistical distribution, discrete or continuous. And there are well-established classical, well-established statistical distribution, well known, their mathematical properties, well tabulated, that you have in the form of the tables or an Excel function in all the textbook now that you deal with. So so what it comes down to, so managing uncertainty by appropriate statistical distribution. Example of discrete distributions are Bernoulli, binomial, Poisson, negative binomial, commonly used. For continuous, most commonly used is a normal distribution, exponential distribution, log normal, gamma, just to name a few. Each distribution has a well-defined probability mass function or density function, and from there you can get a unique cumulative distribution function. So each distribution has unique density function or probability mass. For discrete we call it probability mass function, for continuous we call it probability density function, and then each one has a unique cumulative distribution function. So that we need to understand. That's if the very first course you take in engineering, very first course in statistics, you take an engineering curriculum. It deals with getting introduced to random variable, the concept of random variable, how it relates to real-world processes, how you represent them by statistical distribution, recognizing whether it's a discrete or continuous. Then for each distribution, understand how you manipulate them. From a problem, sometimes you have a problem signature that tells you, oh, I'm dealing with a discrete and it's a binomial. Or I'm dealing with a discrete random variable and this can be represented by Poisson. So there are signatures for that. But what you need to do, and the distribution will not be given to you in a real world. You got to analyze data or use the theoretical support that is behind each distribution to select an appropriate probability distribution. And once you get the distribution, it has a, well, like I said, well-defined probability function, probability mass function or density function, and a cumulative distribution function. The cumulative distribution function plays a very important role because it maps the cumulative probability for the random variable, which is always between 0 and 1. 0 means it's uncertain, the event will never happen. 1 is certain, it will always happen. And you got a number in between. So the idea, so what you learn in that first course is how to manipulate the distribution, how to manipulate their probability function, and how to go from a probability function to a cumulative distribution function, how to use the cumulative distribution function to find out what is the probability the random variable takes values between 2 bounds, or greater than a bound or less than a bound. Those are the typical kind of problem that you see in a real world. So what happens? You learn how to manipulate those basic distribution, and it's very important. It's very important to understand how to manipulate the probability function and cumulative distribution function. And once you get the probability, then it's a problem specific. Later on, we may talk about a warranty problem where I can find out from the probability distribution what is the warranty cost, because I'm providing a 2-year warranty for a product that I'm selling. What happens if I increase it to 3 years of warranty? Or what happens if I reduce it to 1 year warranty? Those sort of things. So now we are converting probability into cost and making decision based on that. So so that's why I couch the term statistical reasoning. So to summarize, you need to understand statistics, statistical analysis of data, because real world is affected by uncertainty, and that's the only way we can handle uncertainty is by modeling the process. Simplest model is appropriate statistical distribution and manipulating the distribution to find out the probability of an event. And of course, depending on how you need that, is impact on the decision that you want to make. So think about this. That's why you need to have some background in statistical analysis. I'm in the field of engineering, but basically anytime you want to work with data from real world processes, you need to understand statistics. Okay, I'll come back with more later on. Okay, bye now. Hi, we are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We'll also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.